Something strange is happening out there far beyond the reach of Saturn's rings, past Neptune's icy grip, and deep into that lonely frontier called the Kuiper Belt. Astronomers, who normally pride themselves on being masters of celestial spreadsheets, are scratching their heads, because some of the icy worlds way out there aren't moving the way they should. Think of it like a choreographed dance. Every planet, every comet, every asteroid has its steps laid out by gravity. Jupiter tugs, Saturn nudges, Neptune twirls at the edge. It's a cosmic waltz. And yet several of these distant frozen objects keep stumbling as though they're hearing a drum beat no one else can hear. Naturally, this has sparked a tantalizing question. Is there someone out there conducting the orchestra? A hidden heavyweight, lurking so far away it's basically a rumor written in ice? Astronomers have a name for it. Planet 9. The mysterious giant we've never seen, but which might be silently pulling strings from the darkness. Now, let's pause here. Because you might be thinking, wait, didn't Pluto already get demoted? And now science wants to add another planet? Are they just making up rules as they go along? Yes? Exactly. Welcome to astronomy, the one science where you can wake up, check the news, and learn that your childhood solar system has been remodeled. The story of Planet 9 is not some New Age conspiracy cooked up on Reddit. It's a saga that began a decade ago, when researchers noticed unusual alignments in the orbits of certain Kuiper Belt objects. These weren't small quirks you could shrug off. No, they were too consistent, too stubborn to ignore. Like finding all your socks missing from the dryer and realizing, okay, maybe it's not bad luck, maybe something's actually stealing them. That's when the whispers began. Maybe, just maybe, there's another world out there. Not a cute icy dwarf like Pluto, but a monster. Something 5 to 7 times the mass of Earth, orbiting so ridiculously far away it would need up to 20,000 years to circle the Sun once. Imagine that. A planet that hasn't even made a single lap around the Sun since humans learned to farm wheat. And so, the chase began. Astronomers started hunting for this elusive giant. But here's the catch. You can't just point a telescope and yell, "Found you!" when dealing with distances like this. The object, if it exists, is faint, slow, and hiding among billions of stars. Which means the search for Planet 9 is less like spotting a new neighbor moving in next door and more like trying to catch a ninja sneaking across your backyard in the middle of a blackout. Still, the idea refuses to die. Every time a new anomaly pops up in the data, Planet 9 becomes more than a hunch. It feels like a ghost at the edge of the solar system, never seen, but impossible to ignore. So, tonight, let's dim the lights, pretend we're looking up at the cold, endless black beyond Neptune, and dive into this mystery together. Because the deeper you go into the story of Planet 9, the stranger and funnier it all becomes. To really understand Planet 9, we need to rewind to where the whispers first started. Picture the early 2010 astronomers staring at data sets of distant Kuiper Belt objects, the frozen leftovers of solar system construction. These objects were supposed to be random little crumbs scattered every which way like sprinkles on cosmic ice cream, but they weren't. Some of them were weirdly aligned, as if pulled into the same general direction, not identical, but suspiciously tidy for something that should have looked like a spilled bag of marbles. This was the first red flag. Because in science, when things line up too neatly, there are only 2 explanations. 1, the universe is trying to tell you something. Or 2, you've messed up the math. And honestly, astronomers live in a constant state of fearing both. The discovery kicked off late-night debates in offices and observatories. Imagine clusters of exhausted scientists fueled by vending machine coffee, jabbing at computer screens, muttering, "No, look, These orbits are pointing the same way. That can't be chance. Meanwhile, someone in the corner is insisting it's just statistical noise, while another is already sketching out models of a massive hidden planet with giddy excitement. The simplest explanation seemed almost too bold. An unseen gravitational force out there, something big, heavy, and unseen was tugging these icy bodies into formation. The invisible hand of a ninth planet. And just like that, the rumor mill of astronomy was in full swing. Planet X theories had haunted the field for over a century, usually to explain things we couldn't quite measure. Most of those theories crumbled under better math or sharper telescopes. But this time felt different. These alignments weren't ancient guesswork. They were fresh anomalies coming from modern surveys, backed by computers that didn't run on punch cards. Of course, not everyone bought it. Astronomers can be brutally skeptical, especially when a theory sounds like something ripped out of science fiction. Some dismissed it immediately, muttering that this was just Pluto revenge syndrome. You know, the guilt scientists still carry after downgrading Pluto in 2006. It's possible they were just looking for another planet to fill the emotional void. But whether you were a believer or a skeptic, one thing was clear. The debate had begun. And once the word new planet hits the public, forget it, everyone wants in. Journalists ran headlines. Planetariums updated their what-if slides. Even your neighbor who can't name all 8 current planets suddenly wanted to know when NASA would find the big one. And all the while, those frozen orbits kept staring back at us, quiet, patient, smug, as if daring us to keep searching. Once the suspicious alignments were on the table, the next question was obvious. What could possibly cause this? That's when simulations entered the scene. Astronomers do what any reasonable person does. When reality looks suspicious, they fire up the biggest computer they can get access to and start throwing hypothetical planets into digital space. It's like running a cosmic version of The Sims. Except instead of deciding which couch looks best in your living room, you're deciding what kind of invisible giant could be bullying icy rocks millions of kilometers away. And guess what? When they added a big planet into the models, something 5 to 7 times the mass of Earth, suddenly everything clicked. The misaligned orbits snapped neatly into place, like puzzle pieces falling together. The icy objects were no longer behaving like drunken skaters. They were obedient dancers, tracing steps in rhythm with this hypothetical heavyweight lurking far beyond Neptune. But here's the kicker. This planet, if it exists, doesn't just sit a little outside Pluto like a polite neighbor. It lives way out in the cosmic boonies, orbiting so far away that one full trip around the sun could take 10,000, maybe 20,000 years. Let that sink in. Our entire recorded history, empires rising, pyramids crumbling, Netflix being invented, has all happened within a single orbit of this planet. If Planet 9 were a student, it would still be stuck on its very first lap around the classroom, while the rest of us have graduated, retired, and died several times over. Of course, simulations can be seductive. When the numbers line up perfectly, it feels like the universe is winking at you. But there's always that little nagging voice in the back of a scientist's head. Are we actually uncovering reality here, or just making the math fit our hopes? After all, humans are masters at finding patterns even when they don't exist. It's why people see Jesus in toast and believe pigeons are government spies. Still, the idea of a hidden super-Earth was too delicious to ignore. For years, astronomers have noticed that our solar system is kind of weird compared to others. Around distant stars, super-Earths are everywhere planets bigger than Earth, but smaller than Neptune. Yet in our neighborhood, it's a no-show. We've got small rocky planets, we've got gas giants, but nothing in between. Planet 9 could be the missing link. The one piece that makes our solar system look like it belongs to the same family as the rest of the galaxy. So, simulations painted the picture. A hulking world drifting in the dark, shaping the fates of icy wanderers, moving so slowly that human history barely registers on its clock. And somewhere out there, possibly right now, it's circling silently, watching us argue about whether it exists at all. The beauty of astronomy is that it never stays quiet for long. Just when skeptics thought the Planet 9 theory was a fun but flimsy distraction, more data started trickling in. Astronomers began tracking the tiny, almost imperceptible wobbles in the orbits of distant icy bodies. And those orbits weren't just quirky, they were off. We're talking about subtle accelerations, little deviations from the paths everyone expected, like a row of dominoes nudged slightly out of place, as if someone invisible had brushed past the table. The math didn't add up. Neptune couldn't explain it. Random collisions couldn't explain it. Even the distant tides of the galaxy, the pull of all the stars combined, couldn't explain it. But the moment they dropped Planet 9 into the models, boom. The anomalies suddenly looked like they belonged there all along. It was as if the universe itself breathed a sigh of relief. Finally, you noticed the elephant in the room. And for scientists, that's an addictive feeling. Imagine spending years staring at nonsense equations, feeling like reality itself is trolling you, and then suddenly the puzzle pieces fall into place with one elegant solution. It's the scientific equivalent of finally fixing the IKEA bookshelf you swore was missing a screw, only to discover the screw was there all along, hidden under the carpet. This is why the Planet 9 debate escalated from cute idea to serious contender. Models don't get tidy like that by accident. And the consistency of the anomalies gave astronomers the courage to say, okay, this might not just be wishful thinking. There could be something real out there. Of course, not everyone was on board. Some rolled their eyes and muttered about gravitational fan fiction. Others compared it to chasing Bigfoot, lots of tracks, no beast. But the growing stack of orbital oddities couldn't be brushed aside so easily. Something was out there, messing with the choreography. Whether it was a planet, a smaller body, or something far stranger, that part was still up for grabs. But one thing was clear. The case was growing more intriguing by the day. And in the middle of it all, one man would soon become the unlikely face of the Planet 9 movement. Every good mystery needs a main character, and for Planet 9, that role fell to Konstantin Batygin. If you've never heard of him, imagine a rock star physicist literally. He's not just an astronomer. He also plays in a band. Yes, the guy who might be responsible for proving the existence of a hidden world at the edge of our solar system also shreds on the electric guitar. Somewhere, Galileo is shaking his head in disbelief. Batygin, along with his colleague Mike Brown, became the loudest and most convincing voices behind Planet 9. And they weren't just daydreaming. These were the same scientists who helped dethrone Pluto in 2006. Which, if you think about it, is kind of hilarious. First they take away a planet, then they say, hey, want a bigger, scarier one instead? It's like an astronomer's version of returning a sweater to the store and walking out with a leather jacket. For Batygin, the evidence was just too compelling to ignore. The alignments, the anomalies, the way the math fell together once you assumed a massive hidden planet, it all made sense. He described the moment of realization like puzzle pieces snapping into place, the kind of eureka thrill that keeps scientists awake for weeks, high on nothing but data and caffeine. Of course, not everyone in the field rushed to line up behind him. Science doesn't work like that. If you want to convince your colleagues, you can't just wave around simulations and say, trust me, bro. You need proof. Cold, hard, undeniable proof. And at that point, Planet 9 was still just a theory, an elegant explanation waiting to be confirmed. But Batygin embraced the role of advocate. He gave talks, published papers, and cheerfully leaned into being labeled the Planet 9 guy. For the public, he was the face of the mystery. For critics, he was the loudest voice to argue with. And for the field of astronomy, he became that necessary figure who pushes the boundaries, knowing full well he might be proven spectacularly wrong. Because that's the thing about science. Someone has to be bold enough to say, yes, there's a giant, unseen planet hiding in the dark. Without voices like that, the big discoveries never get made. And so, with Batygin and Brown at the helm, Planet 9 went from a whispered hunch to a serious debate. The hunt was officially on. If Planet 9 was really out there, then surely it must have left some kind of breadcrumb in the archives, right? After all, astronomers have been pointing telescopes at the sky for decades, hoarding data like cosmic librarians. And so the hunt turned backward into dusty survey catalogs from the 1982nd and 2002nd. One promising clue came from IRAS, the infrared astronomical satellite that scanned the heavens way back in 1983. Think of it as the first big all-sky camera in the thermal spectrum designed to catch faint, glowing heat signatures that ordinary telescopes missed. Buried in its mountains of data, researchers spotted something faint, something moving. At the time, no one thought much of it. But years later, with Planet 9 in the headlines, that tiny flicker suddenly looked suspicious. Fast forward 2 decades, the Japanese Akari mission, 2006-2011, swept the skies again in infrared, and once more, a faint moving object was noted. Cross-reference the two? Bingo. An object appears in both sets of data. For a moment, hearts raced. Had we accidentally photographed Planet 9 before we even knew to look for it? But then, reality, the eternal party crasher of science, showed up. The orbital tilt didn't match. Instead of a graceful hidden super-Earth, the object looked wrong. Too steep, too odd. Like mistaking a stranger for your long-lost cousin because they were wearing the same hat. The match just didn't hold. And that's the frustration of astronomy. You can stare at the same patch of sky for years and think you've nailed it only to realize your supposed new planet is just another wandering rock doing its own thing. In a way, it's humbling. The universe is under no obligation to tidy itself up for our convenience. Still, the IRAS and Akari hints were important. They proved that if Planet 9 was real, it could hide in plain sight, invisible to casual surveys but detectable with careful eyes. The problem wasn't that we weren't looking. It was that we didn't yet know how to look, like spotting a chameleon on a green leaf. It was always there, we just hadn't trained our brains to see it. And so, the mystery deepened. We had old photographs, strange tilts, maybe clues, and maybe mistakes. It was as if Planet 9 was leaving us little riddles in the starlight, daring us to keep guessing. Here's the thing about chasing invisible planets. Just when you think you're closing in, the evidence pulls a U-turn and laughs in your face. Planet 9's trail was no different. For every neat alignment, or promising anomaly, there came an object that broke the rules. Take Ammonite, a distant dwarf planet discovered with the Subaru telescope. Instead of orbiting in a way that confirmed the Planet 9 picture, Ammonite did the opposite. It had a long, stretched-out orbit that was perfectly stable, completely unbothered by any hidden giant. If Planet 9 were really out there tugging on strings, Ammonite should have been dancing along with the others. But it wasn't. It stood there smugly, like that one guest at the party who refuses to join the group photo. For Planet 9 believers, this was frustrating. Every theory loves supporting actors, not hecklers. But Ammonite was exactly that. A heckler in orbit, pointing out that maybe, just maybe, The neat clustering of orbits was an illusion, not a signature of something massive lurking in the dark. And Ammonite wasn't alone. Other discoveries also seemed to misbehave, following paths that didn't bow politely to the invisible heavyweight. It was as if the solar system was split between two camps. One group of icy objects screaming, "Planet 9 is real!" while the other shrugged and said, "Nah, we're good without it." This is the maddening beauty of science. Every clue you find is balanced by another that pokes holes in your theory. You build a castle of evidence, and then some dwarf planet casually strolls up and knocks out a few bricks. Suddenly the elegant idea starts to wobble. Yet here's the irony. These contradictions didn't kill the Planet 9 debate. They made it more interesting, because now astronomers had to ask, are we chasing the right explanation? Or are there multiple forces at play, shaping the orbits in ways we still don't understand? Like detectives at a crime scene, they weren't sure if they were looking at the work of one culprit or several smaller ones. But one thing was clear: the outer solar system wasn't going to give up its secrets easily. As if the case weren't messy enough, 2017 brought another curveball. Astronomers identified yet another distant object, drifting along on a path that didn't fit the Planet 9 predictions. If the earlier anomalies had been puzzling, this one felt like the cosmic equivalent of a rude heckle during a lecture, disruptive, unavoidable, and a little embarrassing for the speaker. The object's orbit didn't neatly cluster with the others. Instead, it wandered off like a rogue actor refusing to stick to the script. For skeptics, this was ammunition. See, if Planet 9 were real, these orbits would all line up like soldiers. But they don't. You're just connecting dots that don't belong together. And they had a point. Science, after all, isn't about cherry-picking the evidence that makes your theory look pretty. It's about wrestling with the awkward data, the misfits, the rebels. And this 2017 discovery was very much a rebel. But for Planet 9 supporters, the story wasn't over. They argued that the universe is messy, and one or two outliers don't erase a larger pattern. After all, if you flip through human history, there's always someone breaking ranks. Ancient armies marched in formation, yet there was always one soldier sneezing or tripping over his own sandals. Why should icy space rocks be any different? So the debate hardened. Was Planet 9 a genuine gravitational puppeteer, with a few exceptions proving the rule, or was it a mirage, conjured by biased data and over-enthusiastic simulations? The 2017 object didn't settle anything. Instead, it sharpened the tension. For some, it weakened the case for a hidden giant. For others, it was just another wrinkle in a cosmic mystery still unfolding. But beneath the arguments, one truth lingered. The outer solar system was far more complicated than anyone had guessed. Whether or not Planet 9 existed, the evidence was telling us something big, something about forces and histories we barely understood. And that's when astronomers started asking themselves, why does this matter so much? Why are we so obsessed with finding one more world? At this point, you might be thinking, why all the fuss? It's just another ball of rock and ice, right? Haven't we already got 8 of those, plus Pluto sulking in the corner? But here's the thing. The existence of Planet 9 would answer one of the most awkward questions in modern astronomy. Why is our solar system such a weirdo? Look around the galaxy, and you'll notice something. Most star systems have what astronomers call super-Earths. These are planets bigger than Earth but smaller than Neptune, and they're everywhere. Every other stellar neighborhood seems to have them, like the cosmic equivalent of a basic IKEA table. And yet, in our solar system, they're conspicuously absent. We've got tiny rocky worlds, Mercury, Venus, Earth, Mars. We've got the gas giants, Jupiter and Saturn, those bloated kings of excess. And we've got the icy twins, Uranus and Neptune, hovering in between. But that sweet spot, that middleweight class of planet, it's missing. Unless, of course, it isn't. Unless Planet 9 is out there, quietly orbiting in the dark, filling the gap, and making us look a little less like cosmic outliers. Finding it wouldn't just be a cool discovery, it would bring our solar system in line with what we see everywhere else. Suddenly, we wouldn't be the odd family at the galactic reunion anymore. We'd be normal. And then there's the bigger picture. If Planet 9 is real, it's not just a bonus planet to put on posters and classroom charts. It would reshape how we understand the solar system's history. Did it form here and get flung outward in some gravitational bar fight billions of years ago? Or did the sun steal it, like a pickpocket snagging a planet from a passing star system? Either way, its story would tell us something about the chaotic adolescence of our cosmic neighborhood. But perhaps the most seductive reason is purely human. There's a deep, almost childlike thrill in discovering new worlds. It taps into the same impulse that drove ancient sailors across uncharted seas and astronauts into space. We want to believe there's still something left to find, that the maps aren't finished, that, in the cold silence beyond Neptune, there's still a secret waiting for us. So no, Planet 9 isn't just an extra rock. It's a missing chapter in our solar system's biography. A reminder that even in 2025, when we've sent probes past Pluto and snapped selfies on Mars, the universe can still surprise us. All right, let's dig into the heart of the Planet 9 mystery, the clustering. This is the piece of evidence that keeps scientists awake at night, staring at spreadsheets with that haunted, just one more coffee look. Here's what they saw. A bunch of distant Kuiper Belt objects, all with their orbits tilted in the same odd direction. Not scattered randomly, not pointing all over the place like spilled marbles, but grouped. Like school kids huddling together on a playground for no obvious reason. Now, randomness is messy. If these objects were truly just drifting about, their orbits should be scattered in every direction. But the clustering wasn't random, it was too neat. And when nature looks too neat, scientists start to twitch. Because in physics, neatness usually means there's an invisible hand at work. Enter Planet 9. Drop a massive, unseen planet into the models, and suddenly those clustered orbits make sense. The hidden giant acts like a cosmic magnet, tugging the smaller objects into alignment, shepherding them into the same corner of the sky. It was an elegant fix, the kind of explanation that makes you feel like the universe is letting you in on a private joke. Supporters of Planet 9 hammered this point home. The odds of such clustering happening by chance were ridiculously low. It was like flipping a coin 100 times and having it land on heads every single time. Sure, it's possible. But at some point, you stop blaming luck and start suspecting the coin. Of course, skeptics weren't convinced. They muttered about data bias and selective sampling. Maybe the clustering was just an illusion caused by where our telescopes happened to be pointing. After all, astronomers don't scan the entire sky equally. They focus on the places they can actually see, while avoiding the crowded glare of the Milky Way, for example. That means the sample of objects we found might be skewed, and the clustering could be nothing more than a trick of perspective. But even with that criticism, the clustering argument remains the strongest pillar for Planet 9's existence. It's not proof, not yet, but it's a tantalizing whisper that something heavy is lurking out there, pulling the strings. And, like all good mysteries, this whisper split the astronomy community right down the middle. The believers, who saw patterns in the ice, and the skeptics, who saw shadows in bad data. Of course, not everyone was buying the neat clustering story. For every astronomer swooning over the elegance of a hidden planet, there was another one with crossed arms muttering, "You're just fooling yourselves." Their weapon of choice? Observational bias. Here's the argument. Telescopes don't scan the heavens evenly. They're limited by geography, weather, budgets, and human patience. Astronomers aim them where they're most likely to succeed: clear skies, dark regions, not smack in the middle of the Milky Way's blinding star clutter. That means certain patches of sky get studied more than others. And when you only look in certain spots, surprise, surprise, you're more likely to find things clustered in those spots. The skeptics liken it to polling your neighborhood Starbucks and then claiming you've uncovered global fashion trends. Sure, everyone you see might be wearing yoga pants, but that doesn't mean people in Mongolia, Peru, or Iceland are doing the same. You're just stuck in a bubble. So, what if these icy objects aren't really huddled together by a giant planet's pull? What if they only look clustered because our telescopes happen to catch the same general direction, like shining a flashlight into one corner of a room and then insisting the whole room looks that way? It's not a bad point. Science is riddled with examples of patterns that evaporated once data collection improved. Think of the old maps with sea monsters drawn at the edges, not because they were real, but because no one had been there yet. Gaps in knowledge breed illusions. For skeptics, Planet 9 might be nothing more than a mirage caused by the way we've been looking. No need for a giant unseen super-Earth. Just a statistical quirk, magnified by human eagerness to find something dramatic. And let's be honest, scientists are still human. They get bored with the ordinary. The idea of discovering an entirely new planet is way sexier than saying, "Oops, our data sample was biased." That's like ordering champagne for dinner only to be told the restaurant is out and all they've got is lukewarm tap water. So, the skeptics warn, don't pop the champagne just yet. Planet 9 might just be a ghost conjured by the limits of our vision. Alright, let's say the skeptics are right and a full-blown super-Earth isn't hiding in the shadows. Does that kill the Planet 9 dream entirely? Not quite. Because some astronomers have proposed a middle ground idea. Maybe it isn't a giant heavyweight at all. Maybe it's a smaller, scrappier world on a tilted orbit. Patrick Liu, a Japanese astronomer, tossed this idea into the ring. Instead of imagining a hulking planet 5 to 7 times the mass of Earth, he suggested something humbler. A body 1.5 to 3 times Earth's mass. Still respectable, but not the monster Battigan's simulations had called for. Think of it as the budget version of Planet 9, still big enough to nudge orbits, but not so large it would have been impossible to miss for decades. The twist? This smaller candidate wouldn't be politely circling in the same plane as the rest of the planets. Oh no, it'd be highly inclined, tilted at an odd angle, like that one person in every group photo who insists on crouching when everyone else is standing. Such an orbit could still account for some of the anomalies we've seen without requiring the grand, dramatic figure of a super-Earth lurking at the edge of the solar system. It's not as flashy, sure. There's less romance in saying, "We found a moderately chubby rock," than "We found a new planet-sized colossus." But science isn't supposed to care about romance, it cares about math. And Liu's math works, at least for part of the puzzle. Of course, critics of this smaller planet model point out that it doesn't fix everything. Some anomalies fit nicely, others remain stubborn. It's like trying to patch a leaky boat with duct tape. Sure, one hole's covered, but water's still gushing in through the rest. Still, the beauty of this proposal is that it shows how wide the range of possibilities really is. Maybe the answer isn't one giant planet, or even one medium-sized planet, but several smaller forces adding up together. After all, the outer solar system is like a cosmic junkyard full of debris, strays, and objects we haven't even catalogued yet. Who's to say the culprit isn't a gang of small troublemakers rather than one big boss? And just when you think the theories couldn't get any stranger, along comes an idea that sounds ripped straight from a science fiction novel. Just when the debate over Planet 9 seemed crowded enough with giants, dwarfs, and tilted orbits. Someone had to drop the wildest theory of all. What if it isn't a planet at all? What if it's a black hole? Yes, really. Some researchers suggested that the mysterious gravitational tug could come from a primordial black hole, a leftover from the very early universe. And not the monstrous kind that swallows stars for breakfast. This one would be tiny, so small you could fit it in your backpack. About the size of a grapefruit, maybe. Here's the fun twist. Despite being no bigger than a piece of fruit, such a black hole could still weigh several Earths. That's because black holes are like cosmic trolls. Small in volume, impossibly dense in reality, and very good at ruining your day. Place one of those out beyond Neptune, and voila, the same gravitational pull as a planet. For astronomers, this theory was both terrifying and hilarious. Terrifying, because the thought of a grapefruit-sized black hole silently orbiting our sun is the kind of nightmare that makes you reconsider ever looking up at the night sky again. Hilarious, because it meant that instead of searching for a planet with telescopes, we might actually be hunting something that, by definition, doesn't want to be seen. Of course, detecting such an object directly is basically impossible with current tools. You can't just take a picture of it. Black holes eat light. Instead, scientists floated ideas like looking for gravitational lensing, the way such a dense object would bend background starlight as it passed by. But that's tricky work, and so far, no slam-dunk evidence has appeared. Still, the mere existence of the Planet 9 is a black hole hypothesis says something about how wide the search has stretched. When faced with unexplained anomalies, scientists are willing to consider nearly anything from a hidden super-Earth to a rogue cosmic fruit bomb. And you know what? That's part of the charm of astronomy. It's a field where the gap between serious science and wild speculation is just a single data point wide. Until you have proof, every crazy-sounding idea is at least worth a shrug and a, well, maybe? So, whether it's a colossal hidden planet or the universe's scariest piece of invisible fruit, the hunt pressed on. But one problem loomed over it all. If something's really out there, why haven't we found it yet? If Planet 9, or its black hole doppelganger, is really out there, you'd think we'd have seen it by now. After all, we've got telescopes snapping photos of galaxies, billions of light years away. Surely spotting something in our own backyard should be easier, right? Well, not exactly. Finding Planet 9 is like trying to spot a single firefly on the far side of a football field while someone shines a stadium floodlight in your face. Distance is the first problem. This thing, if it exists, is so absurdly far out that sunlight barely reaches it. And what little light it reflects is faint, swallowed up by the sheer blackness of space. To a telescope, it's just another dim dot among billions of stars. Then there's the issue of speed, or rather, the lack of it. Close-in planets like Jupiter whip around the Sun in a dozen years. Even slowpoke Neptune does a lap in 165 years. But Planet 9? It's crawling. One orbit could take up to 20,000 years. Imagine trying to catch movement in real time. It's like waiting for your houseplant to grow an inch and hoping to film it without missing the shot. That means, if you take two pictures of the same patch of sky a year apart, Planet 9 would hardly shift. It would blend right in with the background stars, smugly invisible. The only way to spot it is through painstaking surveys, comparing images taken years apart, pixel by pixel. And even then, you have to know where to look. Which brings us to the third problem. The sky is enormous. Even if you narrowed the search to the outskirts of the solar system, you're still left with a haystack the size of, well, the sky. And somewhere in that haystack, maybe, is a faint pinprick of light that doesn't belong. No wonder astronomers haven't nailed it down yet. It's not that they're lazy or incompetent. It's that the task is like finding one lost sock in a laundromat the size of a continent, and the sock is moving, slowly, mockingly. Still, that hasn't stopped them. The search continues, fueled by equal parts hope, math, and stubbornness. And just when it seemed impossible, a new telescope entered the story, one that might finally tip the scales. If the hunt for Planet 9 has felt like wandering around with a broken flashlight, the Vera C. Rubin Observatory is the upgrade everyone's been waiting for. Nestled in the mountains of Chile, this observatory is about to become the cosmic equivalent of a stadium floodlight, except instead of lighting up a football field, it's designed to light up the universe. Here's the magic. Rubin isn't just another telescope peeking at a narrow patch of sky. It's built for wide-field surveys. That means it can capture massive swaths of the night sky in a single shot, with a sensitivity sharp enough to notice the faintest flickers. For Planet 9 hunters, this is like finally getting a drone to search the forest after years of crawling through the underbrush with a magnifying glass. Starting soon, Rubin will begin a project called the Legacy Survey of Space and Time, LSST for short. And no, that's not some Marvel movie title, though it does sound like one. Over 10 years, it will scan the entire southern sky, again and again, building a kind of cosmic time-lapse. Every faint dot will be catalogued, tracked, and compared. If something is moving slowly out there, be it a super-Earth, a rogue planet, or yes, a grapefruit-sized black hole, Rubin's watchful eye might finally catch it. The anticipation in the astronomy community is palpable. Think of it like opening night for a blockbuster film, except the popcorn is stale datasets, and the audience is made up of people who argue passionately about orbital mechanics. Optimists whisper that Rubin could find Planet 9 within its first few years of operation. Pessimists mutter that it might finally rule out much of the space where Planet 9 is thought to hide. Either way, answers are coming, and the stakes couldn't be higher. If Rubin succeeds, it won't just confirm the existence of a hidden world, it will make history. A new planet in our solar system, discovered in the 21st century, would be a headline for the ages. It would reshape textbooks, trigger fresh space missions, and prove that even in an era of satellites and smartphones, the cosmos can still surprise us. So, the stage is set. Rubin is ready. The lights are about to go on. And somewhere, perhaps, a lonely world is waiting to be found. All right, let's play with the most thrilling possibility. Rubin does its job, the data comes in, and boom, there it is. A faint moving speck that refuses to sit still like the background stars. After years of whispers and simulations, we finally get to say it. Planet 9 is real. The ripple effect would be enormous. First, history. Imagine being alive at the moment a new planet is added to the solar system roll call. It hasn't happened since Neptune was spotted in 1846. That's nearly 2 centuries of planetary status quo, broken in a single discovery. You, me, all of us, we'd be part of the generation that expanded the map of the solar system. The "Where were you when Planet 9 was found?" stories would practically write themselves. Second, science. A confirmed Planet 9 would instantly become one of the most valuable natural laboratories in the galaxy. Is it a rocky super-Earth with a thick atmosphere? An ice giant cousin of Neptune? A frozen core with mysterious layers? Each possibility would tell us something new about how planets form. And you can bet space agencies would start sketching up missions, probes, orbiters, maybe even a flyby. Because who wouldn't want to visit the most elusive planet in the neighborhood? And then there's the philosophical punch. For decades, we've been a solar system without a super-Earth, the oddball family missing a middle child. Planet 9 would erase that weirdness. Suddenly, our little corner of the galaxy would look much more typical, much more normal. Funny, isn't it? We've always wanted to feel unique, but in astronomy, being average is the real prize. It means our models work. It means we're not the exception. But the most exciting part? The mystery wouldn't end with discovery, it would only begin. We'd start asking new questions. How did it get there? Was it born alongside the other planets and then flung outward by a gravitational bar fight with Jupiter? Or was it kidnapped, a wandering orphan planet stolen from another star? Its very existence would be a clue about the chaotic early days of our solar system. And let's not forget the romantic thrill. Finding Planet 9 would remind us that exploration isn't over. The maps still have blank edges. Even after we've sent probes past Pluto, the cosmos still has secrets tucked away, waiting for patient eyes and stubborn hearts. So yes, if Rubin finds it, it would be historic, scientific, and poetic all at once. The kind of discovery that makes you feel small, and yet proud, for being a species stubborn enough to keep looking. Now, let's flip the coin. What if Rubin scans the skies for years, catalogs every faint speck, and still nothing? No planet, no grapefruit-sized black hole, no cosmic heavyweight lurking in the shadows. Just icy rocks doing their icy rock thing, leaving astronomers with a mountain of data and a hole where their theory used to be. Would that be a failure? Not at all. Because in science, a no can be just as powerful as a yes. A null result would force astronomers back to the drawing board, sharpening their models and peeling back assumptions they'd taken for granted. The anomalies in those distant orbits wouldn't disappear, they'd just need a new explanation. Maybe it's not one big culprit, but a swarm of smaller ones, dozens, even hundreds of icy bodies, quietly tugging on each other in the cold dark. Maybe we've been fooled by biases in where and how we search, mistaking shadows for patterns. Or maybe there are subtle gravitational effects we don't fully understand yet, tiny nudges from forces we haven't accounted for, hidden in the mathematics of orbital mechanics. And there's a kind of beauty in that too. Because the story of science isn't a straight path to the truth. It's a winding road with detours, wrong turns, and dead ends that still lead you somewhere unexpected. Even if Planet 9 doesn't exist, the hunt for it will leave us with a vastly richer picture of the outer solar system. We'll know more dwarf planets, more Kuiper Belt objects, more little icy weirdos than ever before. The map of our solar system's outskirts will be sharper, fuller, stranger. And that's the thing. Exploration never wastes time. Columbus was looking for India when he bumped into the Americas. Astronomers went looking for a ninth planet and ended up discovering just how messy, diverse, and surprising the edge of our solar system really is. So if Rubin comes up empty-handed, don't expect headlines about disappointment. Expect headlines about new mysteries. Because when the universe tells us no, it usually follows with a sly, quiet, "But look at this instead." Even if the Vera Rubin Observatory becomes the crown jewel of the Planet 9 hunt, astronomers aren't putting all their cosmic eggs in one basket. They're already cooking up other clever ways to sniff out a hidden world or whatever strange thing might be impersonating one. One idea is gravitational lensing. Think of space like a giant trampoline. Place something heavy on it, and it bends. Light, traveling across that bent surface, curves too. So if a super dense object, say, a black hole the size of a grapefruit is drifting around out there, it might betray itself by bending starlight in tiny, fleeting ways. The trick, of course, is catching that moment. It's like waiting for a single raindrop to ripple a pond and hoping you're staring at the water when it happens. Then there are proposals to look for dark matter interactions. If Planet 9 isn't a planet but some exotic object, it might interact with the mysterious dark matter that fills the cosmos. Detecting faint, unusual signals could be a way of indirectly saying, "Aha, something heavy and strange is out there." Is it a long shot? Absolutely. but astronomy thrives on long shots. Meanwhile, the more practical approach continues, cataloging distant trends, Neptunian objects one by one. Every icy rock discovered adds a new dot to the map, a new clue in the puzzle. The more dots we have, the clearer the pattern becomes or doesn't. It's painstaking work, but it's how science builds momentum. Slowly, brick by brick, until the wall of uncertainty either stands firm or collapses under its own contradictions. And beyond all this, there's the quiet hope of surprise. Science often stumbles into answers it wasn't looking for. While chasing Planet 9, we might discover something entirely unexpected: new dwarf planets, bizarre orbital resonances, or even evidence for forces we haven't imagined. Sometimes the best discoveries are the accidents, the oops, didn't mean to find that moments. So yes, Rubin may lead the charge. But the hunt for Planet 9 is already spilling into other methods, other theories, other bold guesses. Because when humanity sets its mind on finding a ghost in the darkness, we don't stop with just one flashlight, we light as many as we can. Here's the thing about chasing Planet 9. Even if the planet never shows up, the hunt has already transformed how we see the outer solar system. Every survey, every painstaking comparison of star charts has turned up new residents of the deep cold. Over the last 2 decades, astronomers have discovered an entire zoo of distant objects, tiny frozen dwarfs, elongated orbits that loop like drunken figure eights, and bodies so far out they make Pluto look downright neighborly. These are the trans-Neptunian objects, or TNOs if you like acronyms. And the more we find, the clearer it becomes. The outskirts of our solar system are not empty. They're wild, chaotic, and full of surprises. Think of it this way. Once upon a time, schoolroom solar system posters showed 8 neat planets, 9 if you grew up in Pluto's glory days, sitting obediently in their orbits like pearls on a string. That tidy picture is gone. The truth looks less like a string of pearls and more like a cosmic junk drawer full of odd shapes, orbits, and leftovers nobody quite knows what to do with. And every time astronomers stumble across a new object, it rewrites the map. Some orbits are stable, looping gently in and out. Others are eccentric, elongated like cosmic slingshots. Some tilt steeply off the solar system's main plane, as if trying to escape the family photo altogether. Each one adds nuance to the mystery. Are they all being nudged by something massive, or are they just colliding, scattering, and following the chaotic rules of orbital chance? Humor me for a moment. Imagine you're building a puzzle without the picture on the box. You keep finding pieces in the strangest places: under the couch, in your shoe, stuck to the cat. You try fitting them together, but every new piece seems to both help and confuse the picture. That's exactly what astronomers face as they keep adding these icy objects to the map. And while Planet 9 still hogs the headlines, these smaller discoveries are quietly reshaping our understanding of the solar system. Even if the big one never shows up, the sheer diversity of what's been uncovered is staggering. The Kuiper Belt isn't some frozen afterthought, it's alive with motion, complexity, and history written in ice. In chasing one ghost, we've ended up with dozens of treasures, and that, in its own way, might be the real reward. Among the new discoveries, one stands out like the class troublemaker: Ammonite, a distant dwarf planet with an elongated, stable orbit that frankly refuses to play by Planet 9's rules. If the Planet 9 hypothesis were a neat crime drama, Ammonite would be the witness whose testimony doesn't fit the script. Instead of orbiting in a way that supports the grand theory of a hidden giant pulling strings, Ammonite looks perfectly content to mind its own business. Its orbit isn't twisted into the same alignment as the others. It's calm, steady, stubbornly normal. And this is maddening, because every neat theory loves compliant evidence. But Ammonite didn't comply. It became a thorn in the side of Planet 9 advocates, an orbital rebel that said, "Yeah, I hear you talking about gravitational clustering, but I'm not moving." For skeptics, Ammonite was gold. Proof, they argued, that maybe the outer solar system didn't need a ninth planet at all. Maybe it's just a messy neighborhood where objects carve out their own weird orbits without any invisible puppet master. But here's the paradox. In science, rebels like Ammonite are not the problem, they're the opportunity. Contradictions force theories to evolve. They demand sharper questions. If all the evidence lined up perfectly, scientists would get suspicious, because reality is never that tidy. Messiness is often a sign you're circling something true, just not seeing the whole picture yet. So instead of killing the Planet 9 theory, Ammonite did something more valuable. It complicated it. It reminded astronomers that even if there is a hidden world out there, its influence might not be the only game in town. Maybe other dynamics are at work. Maybe the story is messier than anyone first imagined. And isn't that the essence of exploration? Every time you think you've got the universe pinned down, it hands you a curveball, a dwarf planet with a stubborn orbit, daring you to keep digging. So yes, Ammonite weakened the clustering argument. But it also strengthened something more important: the humility to accept that our models are only shadows of reality and the cosmos is under no obligation to behave according to our expectations. Just when the dust was settling around Ammonite's rebellious orbit, along came another troublemaker. In 2017, astronomers spotted a new distant object, yet another icy loner, drifting on the solar system's fringe. And, just like Ammonite, this one didn't fit neatly into Planet 9's grand choreography either. Its orbit wandered off script, tilting and stretching in ways that didn't quite line up with the nice, clustered pattern Planet 9 was supposed to explain. For the skeptics, this was déjà vu all over again. Another rebel. Another nail in the coffin for the idea of a hidden gravitational giant. And you can imagine the size in observatories around the world. Because in science, anomalies are both a blessing and a curse. They're the annoying students in class who keep raising their hands to say, actually. They slow you down, but they also make you think harder. For the Planet 9 advocates, the 2017 discovery wasn't a death blow, it was a challenge. They argued that the outer solar system is like a messy classroom. Most of the kids might be clustered in one corner, but of course there'll be a few loners hanging out by the window. The existence of outliers doesn't erase the larger trend, it just proves the universe isn't tidy. And to be fair, they have a point. If everything lined up too perfectly, that would almost be suspicious. Nature loves quirks. Messiness is often the rule, not the exception. The question is, how much messiness is allowed before the whole theory collapses? So, the 2017 object joined the growing cast of characters in the Planet 9 debate. Another data point that didn't quite fit. Another reminder that the truth is rarely simple. Was it evidence against Planet 9? Maybe. Or maybe it was just proof that we still don't fully understand the gravitational politics of the solar system's outer frontier. Either way, it deepened the story. Because now, astronomers weren't just asking if Planet 9 existed. They were asking something bigger. What is really shaping this chaotic wilderness beyond Neptune? So why does all this matter? Why spend years arguing about icy rocks wobbling in the dark? Well, because the stakes go far beyond bragging rights for whoever gets to say, "I found a new planet." Planet 9 isn't just about adding another marble to the solar system's shelf. It's about rewriting the story of how our entire neighborhood came to be. If Planet 9 exists, it means our models of solar system formation have been missing a major player all along. It would suggest that the early solar system wasn't just a tidy arrangement of planets gently settling into place, but a chaotic brawl where giants shoved each other around, flinging one of their own to the outskirts. Or maybe it wasn't even born here at all. Maybe it was a stolen world, captured from another star system during a close cosmic brush billions of years ago. Either scenario forces us to reimagine the solar system's adolescence not as orderly, but as wild and violent. And beyond formation stories, there's the question of identity. For decades, astronomers have been quietly embarrassed by the fact that our solar system doesn't look like most others. Around other stars, super-Earths are everywhere. But in our system, they're absent, as if we're the odd family at the galactic reunion missing a middle child. Confirming Planet 9 would solve that problem instantly. Suddenly, we'd look normal, predictable, average, which, in astronomy, is the dream. Because if our system is typical, then our models apply universally. On the flip side, if Planet 9 doesn't exist, that's fascinating too. It would mean the anomalies are whispering about something else entirely, some new law of orbital dynamics, some subtle effect we haven't cracked yet. Either way, the hunt forces science forward. But maybe the biggest stake is human, not scientific. Because let's be honest, we like maps that have blank edges. We like believing there's still something unknown waiting for us out there. Planet 9 isn't just a celestial object, it's a symbol. A reminder that even in the 21st century, after we've landed rovers on Mars and sent probes into interstellar space, the universe can still surprise us. So when astronomers argue about Planet 9, they're not just debating data points, they're debating whether the cosmos is still hiding secrets in plain sight. And that question, the possibility of discovery itself, is what keeps us looking up. To really grasp why Planet 9 matters, we have to zoom out not just beyond Neptune, but beyond our solar system entirely. Because out there, across the galaxy, patterns emerge that make our little planetary family look suspiciously incomplete. Here's the big one. Most of the star systems we've studied are full of super-Earths. These planets, sitting neatly between Earth and Neptune in size, are the galaxy's best sellers. Some are rocky like oversized Earths, others are mini Neptunes with thick atmospheres, but either way, they're everywhere. Statistically speaking, they're the rule, not the exception. And yet, look at us. We've got Mercury, Venus, Earth, and Mars on the small side. Then, like someone skipped a few chapters, we jump straight to gas giants, Jupiter and Saturn. Sure, Uranus and Neptune hold the middle ground, but they're ice giants, not true super-Earths. It's like building a staircase and leaving out two steps in the middle. You can still climb it, but it's weirdly uncomfortable. That's why the Planet 9 hypothesis feels so tantalizing. If a super-Earth really is lurking in the shadows, suddenly our solar system would snap into the galactic pattern. We wouldn't be the oddballs at the cosmic reunion anymore. We'd be average, and in astronomy, average means predictable, which is priceless. It means we can use what we see here to understand what's happening out there, and vice versa. And this isn't just abstract. Patterns matter because they help us answer the biggest questions. How planets form, why systems evolve the way they do, and yes, the one that makes everyone sit up straighter. Which kinds of systems are most likely to host life? The more we know about what's normal, the better we can spot what's special. Planet 9, if real, would make us normal. And ironically, that would make us extraordinary. Because it would prove that even here, in our well-mapped backyard, the universe can still surprise us with a missing piece we didn't know we were missing. Behind all the equations, telescopes, and orbital models, there's something we shouldn't forget. Real people are driving this search. And the human side of the Planet 9 hunt is almost as fascinating as the science itself. Picture it. Astronomers hunched over computer screens at 3 a.m., sipping stale coffee, muttering to themselves as they tweak simulations. Nights spent staring at star fields, pixel by pixel, praying that one faint dot shifts just enough to betray itself as not a star. It's meticulous, exhausting, and frankly, thankless work. No one gets famous for cataloging Kuiper Belt objects number 547 through 612. But someone might get famous for finding Planet 9. That carrot at the end of the stick keeps the hunt alive. And then there's the obsession. Ask any astronomer in this field and you'll hear it. The gnawing thought that maybe tonight's data will be the one. Maybe they'll be the one to see it first. Science isn't just methodical, it's emotional. There's pride, rivalry, hope, and even a bit of superstition in the mix. Some astronomers joke about jinxing their search by talking about Planet 9 too much. Others form quiet little teams, sharing hunches and suspicions like gamblers, whispering about a winning horse. Meanwhile, the rest of the world peeks in with a mix of awe and amusement. The headlines are flashy. A new planet may exist, but the grind behind them is slow and brutal. For every flashy news story, there are months of dead ends, blurry images, and false alarms. It's a little like panning for gold. You sift through mountains of mud for the faint chance of a sparkle. And yet, the human drive doesn't fade. Because whether Planet 9 is real or not, the chase itself scratches a very old itch. The one that's been with us since we first looked up at the night sky and wondered what was hiding in the dark. Discovery isn't just about results. It's about the thrill of the hunt, the long nights, the shared frustration, and the stubborn refusal to stop asking, what if? So, when you hear about Planet 9, remember, it isn't just numbers and simulations. It's people, tired but grinning, chasing a ghost with nothing but their wits, their computers, and an unshakable faith that the universe always has one more secret to share. And so we arrive at the edge of the story, or at least the edge for now. Because Planet 9 itself still sits in limbo, a theory, a hope, a shadow in the mathematics. What's remarkable is not that we've found it because we haven't. What's remarkable is how much this ghost has already given us. The search for Planet 9 has transformed our picture of the solar system's outer frontier. We now know the Kuiper Belt isn't some quiet ring of leftovers. It's a riot of strange worlds, each with its own personality. We found dwarfs with tilted orbits, outliers that defy patterns, and objects that hint at dynamics we still don't fully understand. Whether Planet 9 exists or not almost feels secondary. Because in chasing it, astronomers have stretched the map, refined their models, and forced themselves to confront how much they don't know. And that humility, the willingness to admit ignorance, and keep searching, is the real heartbeat of science. But let's be honest, part of us wants it to be real. Because there's something magical in the idea that even in 2025, when we've sent probes across the solar system and filled the internet with high-definition images of Mars, there might still be a whole planet hiding in our backyard. Something massive, mysterious, orbiting in silence while we argue about its existence. If Rubin finds it, history will cheer. If Rubin doesn't, science will adapt. Either way, the story isn't ending, it's unfolding, because the solar system is not a finished book. It's a manuscript still being written, full of smudges, corrections, and margins waiting for new notes. So here we are, left with a question that keeps astronomers awake at night and dreamers staring at the stars. Will we discover a new world or discover that we don't need one? That, dear listener, is the beauty of the hunt. The mystery remains. The answer waits, somewhere in the dark,